Now let's move on to mixing and flocculation. Mixing, or rapid mixing as it is called, is the process whereby the chemicals are quickly and uniformly dispersed in the water. Ideally, the chemicals would be instantaneously dispersed throughout the water. During coagulation and softening, the chemical reactions that take place in rapid mixing form precipitates. Either aluminum hydroxide or iron hydroxide forms during coagulation, whereas calcium carbonate and magnesium hydroxide forms during softening. The precipitates created in these processes must be brought into contact with one another so they can form flux. So flux is formed after coagulation. This contacting process is called flocculation and is accomplished by slow, gentle mixing. On the other hand, rapid mixing is probably the most important physical operation affecting coagulant dose efficiency. The chemical reaction in coagulation is completed in less than 0.1 second. Therefore, it is imperative that mixing be as instantaneous and complete as possible. Rapid mixing can be accomplished within a tank with a vertical shaft mixer or within a pipe using specialized mixing systems. Other methods such as partial flumes, hydraulic jumps, baffled channels, or air mixing may also be used. The volume of a rapid mix tank is calculated using the equation shown below, where V is the volume of the reactor, Q is the flow rate, and T subscript D is the detention time. So these are the example of the rapid mixing devices. We have here the turbine chamber, the propeller chamber, the double compartment turbine chamber, the double compartment turbine chamber, also a paddle chamber, and inline blender. So in industry, the commonly used for jar testing is this double compartment turbine chamber. And there are also multiple compartment turbine chamber that uses turbine. So rule of thumb for rapid mix tank design: it has been found that the design liquid depth should be 0.5 to 1.1 times the basin diameter or width. So it depends on the designer. The impeller diameter should be between 0.30 and 0.50 times the tank diameter or width. And the vertical baffles should extend into the tank about 10% of the tank width or diameter. These are the examples of the different paddles used. We have the axial flow, the propeller, and the turbine. So turbine is the commonly used type of paddle. Now let's try to solve a problem related to rapid mixing. The abandoned Cape Kiel Street water treatment plant is to be turned into a research facility treating 0.044 cubic meter per second. A low turbidity iron coagulation plant has been proposed with the following design parameters. We have the rapid mix to 10 seconds, water temperature of 18 degrees Celsius, and the problem is asking to size the rapid mix basin. Okay, so let's start. So we have the formula for the volume, which is equal to the volumetric flow times the detention time. So for this problem, we have the volumetric flow of 0.044 cubic meter per seconds. Then multiply by the detention time, which is 10 seconds. So we have 0.44 cubic meter for the volume. So for the depth, based on the rule of thumb, it should be 0.5 to 1.1 times its diameter. As a designer for this problem, I decided to have 0 as my constant and then multiplied by the diameter. Okay, so volume of the cylinder, it's pi over 4 d raised to the second power times its depth. And we have the volume already, the 0.44 cubic meter. is equal to pi over 4. Then we are looking for the diameter here. So 0.75 d. So our diameter here is equal to 0.907 meters. But it is impossible to manufacture or fabricate this dimension since in the fabricating shops or the fabricating companies, the standard is a whole number. So let's make it 1 meter. Okay, so we have to calculate now again for the volume. So pi over 4. Then our diameter now is 1 raised to the second power times 0.75 times 1. Okay, so our new volume now is 0.59 cubic meter. So our detention time is equivalent to 0.59 cubic meter divided by 0.044 cubic meter per seconds. So our detention time is equivalent to 13.4 seconds. Okay, so this is the detention time, and for the volume we have 0.59 cubic meter. So we already sized the rapid mix basin. That's all for the part 1 of this topic. Thank you.